Today we will be solving CodeChef 137 Double Trouble. Alice has n magical balls placed on the x-axis. You are given the coordinate of the ith ball and it has a certain power. You can do the following at most twice. Choose an index such that the ball is not activated. Activate the ball. Choose a direction for it, either left or right. Okay, and your goal is to activate every ball. Okay, and you need to use at most two moves. Okay, at most two moves. Okay, and this is important. If it never strikes another ball, it simply stops after moving a distance of pi units, which means if a ball is going right and it does not encounter a ball under p of I distance, it will stop, and that is what we don't want. Okay, if it hits another ball, then that next ball will continue ahead. So basically it's a chain. Okay, we can solve this sum very easily by two pointers. This is a very good two pointers question. Okay, since we need to think about chains. Okay, if I have a sequence of balls and I have at most two moves and each ball can go either left or right, then my cases are either I will go both balls left, I can go both balls right, or I can go one left, one right. Okay, so for both left or both right, it is very easy. You can simply brute force it and check whether are you able to form the complete chain in two or one moves. The main question or the main difficulty arises for one left or one right. Basically these problems where if you are choosing this ball, then you want to check if you push this ball to the left and this next ball to the right, or reverse this to the left and it's next to the right, then are you able to collide all balls or not. So this is how we will be going forward for it. So we are going to be using two arrays, left and right. This is how both of the arrays work. For left array, left of I will indicate if I release, means if I activate the ith ball, till which ball is it able to activate. That is what I need to find. Now, naive approach of this is n square if you are checking for every ball. But we can make it over n very easily using a two pointer technique. Now, let's say I have left off some value 5, which is equal to 2, which means if I activate the fifth ball, it can go till second ball, and I want to find the value of left of 6. Then I just need to check if sixth ball can activate the fifth ball. If the sixth ball can activate the fifth ball, that means left ka answer is also 2, because the fifth ball will eventually go to hit the second ball. So if from the sixth ball I can hit its I minus 1 ball, which means the answer is directly the previous one. Else what will the answer be for it? If I can't hit the fifth ball, the answer for left of 6 will be 6 only, right? Now, similar for right, just we will be iterating in reverse fashion. If I have a value right of 7 is equal to 9, which means if I am activating the 7th ball to the right, it will hit up to the 9th ball. And I want to find the value of right of 6. Then I will just check if I can hit the ball from, if I can hit the 6th ball to the 7th ball. If yes, right of 6 also becomes 9, else right of 6 will become 6. That is it. So, first of all, calculation of left and right arrays. You start with left of 0 is 0, okay, and you need to check if the distance is less or equal than your power. In my A array I have stored distance, in my B array I have stored power. So if my distance is less than or equal to my power, which means I can hit that ball, so left of I becomes equal to left of I minus 1, else left of I is equal to I. And for right, same process in reverse. I put right of n minus 1 is equal to n minus 1, and then if the distance is less than or equal to the power, right of I becomes right of I plus 1, else right of I becomes I. Now we have got our left and right array values. Now we just need to find whether is it possible to activate all the balls in two moves or not. So case 1 is complete left. So I will have to start with the zeroth ball if I'm going with complete left. Sorry, this is complete right. Okay, complete right. Now I will have to start with the zeroth ball and go completely right. So I will have to check right of 0. Whichever value this is going, suppose x. Then if I can activate the x ball from 0, which means next I have to check right of x plus 1. If this is equal to n minus 1, that means I can reach my last ball from this x plus 1th ball. And that means in two right moves I have reached the final area. So the answer is yes. Second case, completely left. Okay. Second case, completely left. So since we are going completely left, we will have to start with left of n minus 1. Let's say the value of this is x. Then I will need to check the left of x minus 1. That should be equal to 0. If these cases are success, it means once I start hitting the balls from the n minus 1, in at most 2 moves it will reach my 0th ball. And this case answer will be yes. Now third case, case 3. We will have to check for one left and one right. So we will iterate this. We will iterate from I till n. Okay, and then we will have to check that left of I is 0 and right of I plus 1 equals to n minus 1. If these two cases are true, which means I can make this case true. So I will check this for every I from 0 to n. And same thing I have done. Instead of left of I and right of I plus 1, I have added one more case over here, that right of I and left of I minus 1, which means instead of I plus 1, just for precaution, I have checked these values as well. Okay, but the thinking is same, that from your ith place you are going one left and the next ball will go right, and you need to check for every I whether is there at least one ball present from where I can do this. And now case 4, my last case. The fourth case is like this: you are going right from 0 and left from n minus 1. So you are calculating right of 0 and left of n minus 1. And if these values are greater than equal to, which means the ranges intersect and I can activate all the balls in at most 2 moves. So If this is right, then the answer is yes. If right of 0 is less than left of n minus 1, that means there are some balls in the middle which are not activated, so that won't work. Now, the last case, case 5. If your code has reached up to this point and it still hasn't found an answer, just directly print no and end the program. That's all you have to do. So, here is my calculation of the left array, calculation of my right array. This is both right operations. This is right of 0 and left of n minus 1. I need basically both difference should be less than or equal to 1. Okay, which means if my if my right of 0 is 4 and left of n minus 1 is 5, which means all the balls still get activated. Okay, so both difference should be less than or equal to 1. That is the case. Okay, then this is for complete left case, and this is for one left and one right for each eye. Okay, thank you guys for watching. Make sure to subscribe to the channel to never miss another tutorial.